All right, today we're going to look at 2-7 proving segment relationships. You have two CLTs. I can write proofs involving segment addition, and I can write proofs involving segment congruence. You do have a postulate to start us off with, postulate 2-9, segment addition postulate. Just reads exactly as it is. If two segments are added together, so if B is between A and C, and we add AB and BC, we get the whole thing, which is AC. And then we have the converse, which is also true. So we are given that PQ equals RS. So here's PQ and here's RS. We're given that those two are equal. They want us to prove that PR equals QS. So the first thing, as usual, we write down our given, which is PQ equals RS, and the reason it's a given. All right, step 2. We are going to take and we're going to add a few things together here. We're going to take PQ and we're going to add QR to it. So we're going to have PQ plus QR. All right, so we have PQ plus QR. Okay, PQ plus QR is going to equal QR plus RS. So QR plus RS. So we know that those two things are congruent or equal because we just added a QR to both sides. So that's just the addition property. All right, so since we added those, we can say that PQ plus QR equals PR. And we can also say that QR plus RS equals QS. And that is because of what you just got, segment addition postulate. All right, so from there, it's pretty simple. We know from right here that this and this are equal to each other, so we can transform and say that this and this are equal to each other. So PR has to equal QS because of substitution. All right, and that's pretty much it. So we go on to the next one. You guys have been wanting to use these for a while now. So we're going to go ahead. We get the congruence segment. So congruent means you can use reflexive, symmetric, and transitive properties. So we don't have to change them to equal all the time. We can use them if they're congruent. So you know these properties already. So instead of having equal signs, now you have congruent signs. So if we look at one of these proofs, we're given that MN is congruent to PQ, and we're also given that PQ is congruent to RS, and that is given. And they want us to prove that MN is congruent to RS. So from the definition of congruency, we can change these around. Okay, this is just to prove that last theorem that we had. So from the definition of congruency, we can say that MN equals PQ and PQ equals RS. All right, so once we go there, now we can start moving a few things around here. All right, because they both have PQ in them, and I hope you realize this, we have MN is equal to RS. And please Remember, the transitive property, because that's what gives you that. And then step 4, we can say that Mn is congruent to Rs because, once again, we did it right here to change it from congruent to equal. Now we can change it back from equal to congruent because of the definition of congruency. All right, we will do more of these when you get into class.